Okay, so today we're going to talk about dilutions. Basically, if we start off with a solution that has a certain molarity or concentration, and we add water to it, what's that going to do to the concentration? It's going to water it down, right? Our molarity is going to go down. Okay, so our number will be smaller. This is kind of a formula that helps us predict what our new molarity would be, how much water do we add to it, those kinds of things. If we want to make like a different concentrated solution, how much water do we need to add to get it to get that concentration? This is something that I use a lot of when I do labs for you guys. For instance, I have what I call stock solutions of acids in the back. Like my sulfuric acid that I make all of my sulfuric acid solutions for is 18 molar. Okay, that's not necessarily something you guys would work with or that anyone would use that would be practical in a lab. But like, for instance, you guys have used 2 molar sulfuric acid. So how did I take that 18 molar and get to 2? I added water, but it's got to be a little bit more scientific like that. So that's that formula that kind of dictates it. Okay. So what you're looking at, just as a general definition, is a dilution is when you guys dilute a solution by adding a solvent. Most cases, your guys' solvent will be water. And then the molarity is going to change. Okay, the molarity is going to decrease. It's going to become more dilute, less concentrated. You can see it. That's all there is. Oh, I'm like, no, this is what it is. Is it off, like, too far towards me to the right? Cool. Now it's way off. Is that better? Now it's way off.
No, it's better now.
You can see it now? I hate this thing. But it, like, I think you, like, I can turn the swivel off on it, but it just does what it wants anyway.
If it doesn't like swivel around.
I will not move a muscle. Oh, that's funny. Alright, so you guys' formula for this, really simple. Basically in the problems, for the most part, I will give you guys 3 of these factors and you guys will need to find the 4th. Okay, not a hard thing. So your formula is M1V1 is equal to M2V2. Okay, what does the capital M mean? Molarity. Okay, V is going to be volume. Okay, so... Oh, those are ones. M1, V1, M2, V2. So your M1 stands for your original molarity. Okay, not 100% of the time, but for most of your general questions, your M1 is going to be the more concentrated. It's going to be your SOX solution, and we're going to be adding water to it and diluting it. Okay, there are certain instances, especially on your guys' worksheet in one of our examples today, where we can actually take a solution and make it more concentrated. What's one way you guys could do that? Adding more of the, like the concentrated stuff, right? The acid or whatever. We could definitely do that. Okay. What else could we do to get it more concentrated? How? Osmosis. Yes, we could do osmosis to take the water out. We could just let it sit out on the counter and evaporate though too. Okay. So you guys could definitely make something more concentrated, boil the water out. Okay. Your acid will stay in there. So those are options. So M1 is your original molarity. V1 is going to be your original volume. How much of that concentrated stuff do we need? Okay. This one's great because you guys can do this in liters or milliliters. Whereas when we were calculating just the molarity of a solution, you guys had to use liters. Okay. Everything had to be converted into liters. Your key with this though is if you guys do your V1 in liters, what should your V2 be in? Liters. If you guys do your V1 as in milliliters, what should your V2 be? Milliliters. Good. Okay. So M2 is going to be your new diluted molarity, and your V2 is going to be your new diluted volume. Again, if you guys use liters on one side, you have to use liters on the other. Same with milliliters. So if I give you guys 750 milliliters as your V1, your V2 is also going to be in milliliters. So if you guys read a question and there's a discrepancy between liters and milliliters, you'll need to convert one so they're both the same, so they're consistent. Got it? All right, page 50, we're going to do 3 examples. Okay, write this down. Your first example says, what volume of a 12 molar solution is needed to make 250 milliliters of a 2 molar solution? Okay, pay attention to this word of. Okay, that generally means those 2 numbers that I've given you are paired together. 250 milliliters of a 2 molar solution. Okay, those are going to be either your 1s or your 2s depending on what the question says. This is very practical. This is what I do in lab. When I have, like when we did the copper lab and you guys had to take that black sludge and turn it blue, I had to get you guys 2 molar sulfuric acid to use for that step. All I have in the back is 18 molar. So basically I had to figure out is how much of that 18 molar solution do I have to use if I only need 200 milliliters and I need a 2 molar solution of it. Okay? So I figure out how much of that concentrated acid I need, and then I add water to it until I get 250 milliliters. Did it move again?
Yeah. Well, I guess even if I adjust the choice of method.
It stayed for a while, though.
Is there some other things to
I think if you hit the little in the front of it, but there's like a little circle, not the power button.
Okay.
What'd you just say?
It should be good.
Don't mess it up.
Right.
Oh, it went back green. Go green again.
Oh, no, definitely.
It's like, hold it down maybe. Because it turned red for a second, then it turned green again.
The light turns off? Oh, okay.
Now try
it's
it.
blinking.
Now try getting it, squared away.
It's kind of weird to...
Slowly dying.
It's like going up. Okay. It's fighting me.
Don't break it.
It wants
It's
to...
expensive. I looked at one of those online. It's like $250.
Oh, wow. Is that gonna... It's...
Turn green again.
Oh, it has more of its...
Okay, just leave it there. Let's see where it goes.
I can just imagine somebody who's watching this video right now.
Yeah, I know.
Wow.
We'll cut this out.
These kids are good with technology. All right, so we know our formulas. M1V1 is equal to M2V2. So, Devaney, do we know M1? Yep, 12 is going to be our original concentration, 12 molar. Sometimes it'll describe that as your stock solution. Just know that that's your concentrated solution that you're going to be diluting. Okay. Do we know our V1, Buck? No, so that's going to be our factor that we're solving for. What's our M1, Ivan, or M2, excuse me? 2 molar, right? What we're going to be trying to make. Okay, we're going to be diluting it to 2 molar. And how much of that 2 molar solution do we need, Vicente? Good, 250 milliliters. Okay, so you guys solve for your V1. Multiply 2 times 250. Divide that by 12. Destiny, what do you come up with? $41.6. So round up 6, 7. And that's going to be what unit label? Milliliters, good. So basically how this would look in lab is I would measure out 41.67 milliliters of this 12 molar solution. Okay? Then I would fill up until I hit with water until I hit 250 milliliters. Okay? So I'd have to add water to it to dilute it. Okay? But I would start with originally this much of my acid. Okay? Fill up to 250 milliliters. That 250 milliliters will have a concentration of 2 molar. Okay? So this is your overall total solution. And that's important that you guys pay attention to because some of the problems, especially on your worksheet today, will ask you how much water do you add to it. Okay? It's important to think, all right, what do we start with? What do we end with? Okay? This is total solution, not just what you added in water. Okay? This is solution, so it's solute plus solvent versus just how much water are we adding to it. Well, whatever the difference between these two would be. Okay? That's how much. This is acid. How much water did we add to get 250? Okay? All right, so your next example. If 50 milliliters of, there's that word again, 18 molar stock solution of sulfuric acid is diluted to 200 milliliters, what is the molarity? Okay, again, we have the formula M1V1 equals M2V2. What is our M1 value, Destiny? Oh, sorry, I'll give you a second to write it down. My bad. My bad. You guys don't already have this down? wizard. It looks really nice out, but I have a feeling it's not really nice out. That makes me want to cry. That's just the wind giving them a kiss. With gale force, freezing winds. I feel like the last couple years have all been very nice. I feel like today, not so much. That's why I brought like a beanie, down jacket, shoes. Shape. Huh? Well, I mean, not flip-flops, nerd. I don't want frozen piggies. Get it? Alright, now do you have it written down? About time. Alright, we've got M1 is 18 molar. Tyler, what's our V1? 50 milliliters. Again, you guys can see those tied together with the word of. I just decided to hold my pen really awkward when I write. Okay, M2, do we know that, Vicente? Nope, so that's going to be what we're solving for. And what's our V2 then? 200 milliliters, good. Okay, multiply 18 times 50 divided by 200. That's going to give you guys your value for your M2. Buck, what do you come up with? 4.5, good. 4.5, what's our unit label for this? Either big M or molar. You guys can write molar, but big M is sufficient. Okay, so 4.5 molar. Easy peasy. Okay, one of your guys' problems on your worksheet look like these two. Okay, super easy. I gave you all the numbers. Okay, the third problem I'm going to show you guys. You guys have to think about. I'm going to make you guys do it yourself. You're going to have to read, visualize what's happening. Draw a picture if you have to. It's not hard. You just like have to think about it. You guys can't just be like, oh, these are our numbers, plug them in. You guys got to think about it. Yes, because I want to see how you guys read and interpret this. Yeah. You get to. Okay. If 1 liter of a 0.8 molar saltwater solution is left on a hot plate and 250 milliliters evaporate, what will be the new concentration of that saltwater solution? So you guys started with the liter of 0.8 molar, and you leave it on a hot plate, 250 milliliters evaporate. What's our new concentration? So when you guys get an answer, raise your hand, I'll come check, and I'll tell you yay or nay. Si or no? 9 or da? Is it da? Yeah? Wait, it is? German? What's, is it, wait, what is Russian? Niet. Yeah, I was going to say it's an N-Y-E-T. So then what's, I thought it was, so someone told me last year you're wrong then. So German is 9 and ja. Good point. So apparently, and this was a trivia question the other day, the English language has the most like character, or not characters, but words, I think it was.
Yeah, it does.
I didn't know that. I figured it would have been Mandarin.
Yeah, well, I think the way they have it, they have like words that represent like a lot of different things.
Okay.
A lot more specific and stuff.
That's fair. I just knew that Mandarin was the most complicated. Like, it's really hard to learn Mandarin. Yeah. And slang. Yo. Ain't that a thing? Hot. H-A-W-T. Pretty hot and tempting. All right. Get this problem solved and raise your hand when you guys get an answer. I'll come check it. Niet. Look at all my new languages I'm learning. Niet. 9.
Wait, no?
No.
What?
Think about what's happening. Visualize it in your head. Truma makes protein.
No, it's probably not right.
Is that the grossest thing I've ever seen, Ty?
It's actually really
Ugh.
Ooh, well, I think this is right. Is this? No. So it's
And I'm on the
So far, so good.
So then you have to take 1,000 less to right?
Boom.
Is that? Okay, so.
Nope.
No, that's the right.
so since that evaporates, you subtract it
Nope.
from
Wait, how did you get the right answer?
Like that.
Yeah, but I was looking at your work. Yeah, that's right, but that's wrong. You have it correct there.
Yeah.
That's right.
I
That's
changed-
the correct answer.
I changed it here, but not
You
here.
see what you did the first time, though?
Yeah, I didn't get.
You gotta really interpret what that question means.
Because
You guys are on the right track now. The only other thing you need to figure out.
Is it wrong? 36?
No, you're fine with your numbers, but look at your.
Oh.
So you gotta change one of them.
How did you get 750
All right, guys. I think for the most part, you guys are somewhere where we could discuss this now. Nope. All right, guys. Let's take a look at this. So this is going to be your visual of the day. Okay, I'm going to have a beaker before and after. Okay, here's my 1 liter beaker before. Here's going to be my 1 liter beaker after. Okay, this is 1,000. This is 500. Okay, so basically what I started off with is I started off with 1,000 milliliters of a 0.8 molar solution. Okay, what the question says is it says that I leave it on a hot plate, and what happens? 250 milliliters evaporate. Evaporate's the key word. Is that our final volume for our M2 or our V2? No, that's how much we lost. What's our final volume? 750, right? We have to take 1,000, subtract the 250 that we lost, and we're going to be at about 750. Okay? And we're going to try to find our new volume of that. Your new molarity of that. Will it be more concentrated or less concentrated? It'll be more concentration, so a higher molarity. Okay? So we look at that. All right, we know M1 is 0.8. We had 1,000 milliliters of that. Remember, if you have it in liters and milliliters, so you either have to convert to milliliters or liters, your choice. You're going to get the same answer no matter what. Okay? I chose milliliters. And then we're going to find our new concentration, M2. And our final volume of that total solution is 750. We lost 250 milliliters. Okay? We can also look at this by saying, what if we were to make it less concentrated, we would dilute it more? How much should we add? What's our final volume? So pay attention to those like little subtle nuances. Okay? Solve for that. What do you guys come up with? .07 molar. Okay? So that's your new concentration. You guys see it's more concentrated than the 0.8 that we started with. Okay? One type of question, the only reason I'm talking about this is because like what we just did is like number 3 on your worksheet. There's 4 problems, BT dub. Okay? Number 4 kind of says, all right, what if we wanted to take this solution, this 1.07 molar solution, and dilute it again? Okay? So the question is phrased differently, and again, you guys have to pay attention to these little subtle nuances. The question asks, how much water would I add to this solution to dilute it back to, not necessarily back, but to a 0.5 molar solution. Okay? So it only gives us one number in this. What are we going to use for our M1? 1.07, what we left off with, right? That's our new original solution. It's our new OG solution. Okay? How much of that did we have? 750 milliliters. Okay? We want our newer solution to be 0.5 molar. We're going to dilute it again. And we need to figure out what our final V2 is. Okay? Go ahead and solve for V2. Let me know what you guys come up with. So 1,605 milliliters. Okay? Does that answer this question I asked? How much H2O would I add to dilute it back to 0.5? Tyler, you say no. Why is that?
because the 1,605 is the total
Right. So how much did we add to it to get 1605? Remember 1605? Your V2 is your total. Everything you have left over at the end. How much did we add to get to 1605? So you guys would solve that how? Right? We started with 750. How did we get 1605? We had to add how much? 855 of water. Just water, right? Because we're just diluting it. Okay? That's it. So I'm going to pass out you guys' worksheet for you. Again, number 3 is like the number 3 example we just did. Number 4 plays off of that. Again, pay attention to those vocab words. The of tells you guys what gets paired together. Okay? And then, like, how much water do we add or what's our total volume? Okay? Those kinds of things. Pay attention to those. The M1V1 equals M2V2 gives you guys the total volumes for those. Okay? Not how much water was necessarily added.